start the last topic, introduction to drone data and analysis. I hope everybody is there. Yes.
Yes, sir.
Okay. So we have so far completed weather and meteorology. Then we talked about drone equipment maintenance. Then we have seen payloads. Then we have done the emergency handling. Different topics we have done. Yesterday we have done topic on drone rules and all the things. So any query you have, any doubt you have, feel free to ask. After this session, we'll have a small session. I will be having open session maybe for 10 minutes, 15 minutes, whatever. If you have any query, we can explore that. Anyway, tomorrow we are meeting physically at the resort. So next 3 days is all ours. Okay. So we can spend as much as time talking about drones and the drone industry. Okay. If you have anything, you can let me know, or I can start with the topic. Introduction to drone data and analysis. No? Okay. So this topic is introduced by DGCA. This is not a topic directly related to the piloting skills, okay, or flying skills. This is only just to give you an overview that whatever the drone you are flying, the type of image, what would be captured and what could be the interpretation. It is just an overview topic. Okay, this is not a detailed topic. We are actually working with couple of vendors on this particular topic, where we are going to start a detailed course on the GIS part. Okay, so this actually is a part of the GIS knowledge. Okay, so where you fly the drone, you capture the images, and then you interpret, you create. I mean, we'll be teaching one or two softwares also, like maybe a Google Earth or ArcGIS is there, ProGIS is there. There are ESRE softwares are available. So there are at least 5 to 10 good softwares are available, which are used worldwide for doing all those kind of photogrammetry kind of activities and all the things. Okay, so we are actually working with couple of GIS analyst people and trying to develop a course. So maybe somewhere around October we intend to start that course. Okay, where we actually maybe introducing not only about the course, but actually flying the drone, capturing the image, and then analyzing your data. That kind of, like, we are trying to do something in a different way, which nobody has done so far in India. A lot of people who does all this activity, they are very at a professional level. Maybe people who have worked in remote sensing organizations or different organizations where these kind of activities are, but this is not available for any other normal people. Like, we might be flying a drone for capturing the images and videos for events, okay, or photography events and all the things, but the other remote part of it, or GIS part, what we can do, or more data what we can. So we actually trying to see whether we can work out with that kind of a course. So we actually are talking with couple of people from the industry who are into this and trying to develop it. So that discussions are still going on, and we are trying to figure it out, because we need to set up that complete course, which will be around 7 to 10 days kind of course would be there. Okay, so this is completely a remote course, so you don't need to travel anywhere unless you are doing some kind of a flying. So depending upon what type of course you are ordering, maybe initial beginner course would be there, or there could be a advanced level course could be there. So there could be a course which could be with flying of the drone and without flying of the drone. Without flying drone will be having a ready-made data sets will be available, but where you want to see the real-time footages of the drones, you can fly the drone and capture and then process based on this. So this is basically an overview of the type of the data what you captures. Okay, so principle of observation, element of image and video interpretation, introduction to photogrammetry, then types of image and video data, and then analysis. So basically, I have used this kind of softwares or this kind of things during my power line tower inspections also. Like initially, as I told you, we were flying the drones manually. So the amount of data what you, so for example, I will say in 1 kilometer, there are at least 3 to 4 towers, not more than that. Okay. So within that range, if I'm capturing an image of one particular power line tower, I used to get initially 300 photographs and roughly 1 or 1.5 or 2 GB of video. Okay. But those data what I used to get by my pilots was not uniform. If same pilot was using his flying skills, probably his way of doing or capturing the image was one type. Another pilot will capture on his own way. Third pilot will do his on his own way. So there was lot of ambiguity. कोई 200 फोटो कैप्चर कर रहा है, कोई 300 कर रहा है, कोई 100 ही कर रहा है, so there was no constant or not type of angles of the photos. Lot of photos were not clear. The photo जो important है वो photo नहीं आ रहा है ठीक, so there was lot of ambiguity. So as I told you that we introduced a company which helped us to design a flight plan. So after that, the dependency of the pilot has reduced. Yes, pilot was required because pilot needs to upload the plan. He need to execute that plan. He need to monitor whether drone is performing the activities properly or not in case of any kind of emergency. Because every tower, every wire, the way the wires are being connected is a different thing. So sometimes you need to tweak the plan also. Okay, in case कोई wire के आसपास जा रहा है, तो we have to hold the drone. Okay, we have to stop the drone or break the drone in that position. Okay, so it has to stop that mission over there, pause that mission over there. Okay, and then we have to correct it, or we may have to do something. So that's why the pilot was required. But then the amount of data what was captured after the auto flying was introduced, the amount of data we used to get almost like 500 to 700 photos. We used to get almost like 3 GB of video data. So we were getting good amount of data and very right way of data. There was no missing points into that. Okay, we were getting all required frames, all required images for analyzing the tower status. Okay, so we were actually finding defects in the towers. So there were 15 to 20 defects, known defects was there, which we have trained. So initially we were actually monitoring manually. So imagine a person sitting like me or you, in front of the laptop, and I'm seeing 500 photos of one tower. So पहले 100 photos I was monitoring, seeing it properly, trying to find the defects from the photo. But it is a very tedious talk. Okay, and we were doing POC for 100 towers only. But the actual project was for 12,000 towers. So think how much amount of data would be generated. Think how much photos to be analyzed. So that was not possible by human. So in a third phase, what we is that we introduced the machine learning. Okay, so we got a software developed for it, which actually where we used to upload the photographs and videos, and within 30 minutes, entire photos were analyzed by the software, and it used to give me a report that so and so photo, so and so location, or whatever it is to find the photo, it is to mark those photos with those defects around it. Okay, and it is to tell, okay, here the member wire is missing, here the nut bolt is missing, or there was a number plate missing, danger plate was missing, vegetation has grown up to so and so height. So all these anomalies what we have fed into the software, we're able to do it. So this is all about the software analysis, software part of the data. Okay, so once we capture the images and the videos, we were able to generate the reports. Manually, initially we tried to do it for 10, 20 towers. It was taking us for weeks time. Okay, so now every time we fed that, within 30 minutes, one tower ka data was available to us, which used to take, a day or 2 days of time of a particular person. Again, it is subject to subject of a person. I analyzing photo and you analyzing photo, or third person analyzing photo, is again subjective to each other. What I see, what I don't see, or what I understand as a problem or a defect, maybe not necessary you will find that as a problem or a defect. So again, it is a subjective. But whereas putting the machine learning software, it was very easy, uniform, the reports were faster, easier and quicker. So that is what is we are thinking from this topic. So this is just the initial introduction about the topic, not in detail or depth. In itself, it requires lot of study, lot of time and efforts to be put up to actually go to the next level of this topic. Okay, so principles of observation is what? Recognizing target is the key to the interpretation and information extraction. So when I see the photographs, what do I extract or what do I interpret from the data? Okay, what do I interpret from that photo? That is what is the, like जैसे हम लोग गेम खेलते हैं ना, there are like lot of time you will see online in Instagram, Facebook, or even in the newspaper, there are two similar photos and you are told to find the defects in the two photos, right? Difference in the two photos. So you are trying to interpret, you are trying to see the differences. So that is what your interpretation, or that is how you are extracting the information. What is missing from both photos? They may be the same photos, but there could be some 5 or 10 points may be changed or missing, or there could be some changes have been done. So you are trying to find that differences. So earlier people used to do this kind of analysis. They used to have two photographs of a same object taken at different intervals, and there was a device, I forgot the name for that. It's called uh, what is that called? Variometer, some meter it was called. So it is basically comparing and giving you overlapping images of both the photos. And by clicking on and off of the images, there is a light on that images. So you just off it. So you just slide. It is a slider switch. You just slide. So एक time एक image दिख रहा है, दूसरा एक time image दिख रहा है. So like that you just slide it very fast. So under the blinkometer, okay, blinkometer. So that blinkometer will actually tell me the difference in those two images. That is how people used to earlier do the comparison of the photographs. They used to analyze. That is what actually the initial part of the photogrammetry what was we are talking. So that is how people used to find the differences. Okay, like that is how the people even in the olden days used to find planets. When they used to take the photograph of a sky, there are a lot of stars in the sky. So if you take today one photograph and after 1 month you photograph, you should see the same star at the same position. But if you overlap those images and you see the difference in the motion in particular object, then you understood that that object is moving across the sky. It could be a planet, it could be a comet or something. Similarly, in the normal day-to-day life RGB photographs, when you compare two photographs under the blinkometer, you can understand the difference in it. Okay, that is how it is. But now, because of the digitalization and everything available, it is very easy. You can just write a program, you can get and see the image. It's pixel by pixel, it will scan and tell you the difference in the image itself. Okay, so that is how you are able to find. So today, because of the digital technology, it is very, very easy. But in olden times, whatever the traditional ways people used to interpret and make the data out of the photographs, a manual photographs were printed also in those days, and people used to, using the magnifying glass, they have to observe and they have to find things into those, because digital photo you can zoom out, but in a physical photo you can't do that, right? So you have to use a magnifying glass to zoom and see the particular photo. Sometimes you can make again a new photograph of bigger size, okay, but then again if you print the bigger side image, probably if your quality of the image is not available proper, you may not have a big photo in a good quality. Okay, so these challenges were there in a traditional way of observation, but because of digital way, you will have lot of advantage to it. So observing the difference between the target and their background involves the comparing different target based on all or any of these visual elements. Like you can find a difference between tone, shape, size, pattern, texture, shadow, or association. Okay, so as I give example of what the planet observation, like we are trying, like Uranus was found like that, Pluto was found by like that. These some planets were found based on the observation. You're taking the photographs on the photographic plates. Okay, so they compare these photographic plates. So in 1930, when the Pluto was discovered through the photographs only, nobody has visually seen that planet. Okay, earlier. So they were only seen the photographs of the Pluto, and that's how they compared that. Okay, that planet is there. Okay, that was actually earlier called as Planet 9. Okay, or ninth planet for it, but later on it was demoted or termed as a dwarf planet. So, but that is a different story in itself. But I am talking about how do you compare the pictures, how do you understand, how to interpret or extract information from these objects using the photographs. Okay, so from tone refer to the relative brightness or color of the object in an image. Generally, tone is the fundamental element for distinguishing between different target or features. Variation in tone allows the element of shape, texture, and pattern to be object to be distinguished. So you can see here there are images. So this is a black and white image, okay, where you can find out the road, the ground, the plantation has been done, or wherever there is a grassy land you can see it. If there is some structure in the ground, you can find out about it. So that's a tonal difference what you see in the image. Similarly, shape, like you can see here, the shape refers to a general form, structure, or outline of individual objects. Shape can be very distinctive clue. Okay, for example, you can see here forest edges, general more irregular shape, expect where man has created roads. You can see the road over here, right? Roads or smaller roads, or the recreational ground, you can see a circular shape grounds are there. Okay, or tracks are there for jogging or walking and all that things. So you can find out from the shapes of the objects what has been captured in the images. Patterns. Okay, patterns refers to as a special arrangement of visually describable objects. See, this is basically an orchid field. Okay, where evenly spaced trees are there, or even if you see houses, complexes are been built. If you take the pictures of that, they are very good examples of a patterns. You can see the same types of buildings, same types of fields, same type of houses, row houses been built. You will see patterns around it. Okay. Size, again, if you see the size, for example, the bigger structure will have a bigger size. Smaller houses, like here you can see in the picture, there is a warehouse, there is a big warehouse or a company setup or a factory setup is there, but there are small houses other side of the road. You can see this probably be a commercial or residential area for the workers who would be working in this warehouse or this particular factory. Okay, so that is how you can interpret. There are roads, there are different roads, big roads, small roads, all that you can interpret from the size. So depending upon picture to picture, the object, the size of the object in image, you can interpret and scale it. Okay, so you will see there are a lot of GIS images which are there, which will give you the size scale also here. So looking at that scale, you can understand the size of that particular object also. Okay, so small building, it could be big building, residential complex, or maybe a zone of lands used. Okay, so you can see here there is a big factory or warehouse is there, but there is all rest of the land is empty. But whereas if you see on this particular land, there are small houses, but it is completely acquired the land. Okay, so there the houses are very close to each other or near to each other. Here you can see there is a one big warehouse, there are small offices over here, there are some small buildings on side. The rest of the land is empty land. Okay, so that is how you can interpret from the picture what is been taken. Then texture, like as we saw, like you see here, these are all trees, this is all barren land or empty land where there are no trees, no grass or anything. But if you can see here, there are grasses here, there are some trees over here, and then their boundaries are uneven. Okay, so their boundaries are uneven, they are not man-made or something, they are naturally developed kind of locations are there. Okay, so from the texture or the tonal variation, what we can see, we can understand the region over there. So texture is one of the most important element for distinguishing features in radar image. So normally this is done under the remote sensing radar imagery or LiDAR imagery, where you will able to get this kind of images. Shadow, again depending upon different type, like as I was told you, gave an example about the power line towers. So normally when we used to take the pictures from early morning 7 o'clock, okay, the moment that we have a sunrise, we have a good visibility of the tower, we used to capture. But during that time, during the sunrise time, till somewhere around 11, still the angle, sun is at angle, so only one particular area of the tower is visible. Okay, the sun which is reflecting the light was visible. So if I'm taking from this area of the drone, I used to get a good quality of it. But the moment I'm in the front of the sun, my images were dark or they were black, so I was not able to get interpreted. The shadow was there, light blackness is there, but again I have to capture in all types of lighting options, so that sometimes shadow was also important for me when I'm capturing the images. So in different timelines I used to capture. I used to capture during the sunrise, even before the sunset, and the best time to capture the tower was between 11 to 3 p.m. Okay, so between that period, that 4 hours period was a golden period for me, because that is the time your sun is more or less on overhead, on the top. So the tower is illuminated on all four sides. So I was able to capture the all images properly. Okay, but then because of the shadow, again the shadow below the tower or inside the tower, there was not very good illumination happening. Okay, so it has its own advantages and disadvantage of the lighting effect that is. But then I have to capture all sorts of images, so that I will see what images I am capturing it. So maybe over the period time I'm tweaking, I'm changing my angle of footages and all the things. Like today we started from east side of the tower, then we went to north, then we went to west, and then we taught south. Next time when we are trying, we reverse the type of photograph. So we started from the south, so we went in the reverse direction. Like earlier we started with east, north, west and south. The next time we capturing from the south, we went in the reverse direction. So we started with south, then we captured west, then we captured north, and then we captured east. So we wanted to see the difference in the images. Okay, so rather starting in the morning in east, I started from the south, and then I captured in other way direction. So both set of images. So every time we used to experiment to find out what differences we would able to get at a different time of the day capturing the images. So shadow was also playing an important information interpreting the images also. So when it was helpful for us during our machine learning activity, when we were training the software to interpret the images based on what it is trying to see, what could be the how sometimes the bolt, the shadow of the bolt becomes dark. So software, when we train, empty hole and a shadow of a bolt looks similar in the picture. Okay, so the software will interpret in both positions there is no bolt in it. But then when we saw that images, so we fine tune the software such that it doesn't have to rely only on one photo. It has to check multiple photos and then interpret on it. So if it tries to rely on one particular photo initially, it was giving us a false reports, a false information. Okay, but then we analyze, we tweak the software such a way that it was able to analyze different images and try to find that particular position from different position and then interpret and tell. Then it is able to identify whether there was really a bolt missing or it was just a shadow effect which was giving us a false impression that bolt is missing. Okay, so we were able to reach out. Initially our interpretation accuracy was somewhere around 55% initially. Okay, when we completed the project, our accuracy was almost around 85 to 90%. Okay, so it requires lot of data to come to that percentage of accuracy. Like for example, if I show a machine learning software of apple. If I show 1,000 apples and 1,000 of one time I show another apple, it will still recognize apple. But if I show a tomato also looks like apple only. So maybe not the machine learning software may not recognize tomato as tomato because I have not fed it how does the real tomato looks. So I have to feed both side of data. One is apple as well as tomato, and I have to tell it what is the difference between it. Then probably it will able to interpret. If I hold tomato and apple together, it will show that apple as apple and tomato as tomato. उल्टा नहीं होना चाहिए, रॉन्ग नहीं होना चाहिए, और मे बी दोनों को एप्पल बोले या दोनों को टोमेटो बोले या इसको टोमेटो बोले और इसको एप्पल बोले. So all these options are wrong. It should say this as an apple and this as a tomato only. Then only my accuracy is 100%. Okay, but not necessarily. Again, when I am trying to show, after I show individually apples, 1,000 apples, different types of apple, different colors of apple, 1,000 types of tomatoes. When I hold both objects simultaneously, one object, when I am holding both objects one same time, it maybe tell me the accurate. That doesn't mean I am 100% accuracy. Even I have to test these both options 1,000 times. अगर वो 1,000 times में 1,000 times right आया तो मेरा 100% है. अगर 1,000 times में 900 times right आया लेकिन 100% 100 times wrong आया, then I am only at 90% of accuracy. You got it? That is how we interpret the accuracy of the software also. Hope I am clear with my examples what I try to tell you about how we interpret about the data from the software. Right? Then last is the association. Like a lot of time when we take the images, there is always a background image or background is there. So what is the association with it? So association takes into the account the relationship between the other recognizable objects or feature in the proximity to target of interest. The identification of features that one would expect to associate with other features may provide. Like sometimes we take a long shot of the towers just to make sure that this tower belongs to which area. So that is the association. So we used to take a lot of longer, wide area photographs just to correlate that, okay, this tower belongs to so and so village and so location. So we try to take some reference point, okay, because all tower, if we go for a close up, will look similar. So how do we understand which tower is for which? So we have to have some kind of association. Okay. So identification of features that one would expect to associate with other features may provide information to facilitate identification. In example given above, the commercial property may be associated with the proximity to major transportation routes. So you can see here there are some transportation routes are there or smaller roads are there. Okay. Whereas the residential area would be associated with the school playground and sport field area. In our example, a lake. Okay, you can see here there is a lake. Okay, and then you can see there are a lot of boats over here. There are boats, and then marina and recreational land is there. So you can see there are people who can spend time over here. Okay, So that's the different features about we can interpret from the images. Types of image and video data. It could be infrared images, near infrared images, night vision, thermal images, multispectral images. Apart from your normal RGB images, okay. So it could be any other like infrared, near infrared, night vision, thermal image, multispectral. So you can see here, this is an infrared image. Then you can see another near infrared image. You can see NDV factor over here, okay. Whereas the same image when you see in RGB, how does it looks? Okay, so you can interpret from here the values of NDVI. Okay, then thermal images, you can see thermal images here. Okay, multispectral images again. Okay, you can see here there are NDV values are there. So higher the NDV values, it is a greener area what would be there. Like if you see 0.8, okay, so these are 0.8 values. Okay, whereas 0.0035, they're reddish. So this could be your barren land. Okay, so this is a cultured land or wetted land kind of thing, green areas. Okay, this could be just the beginning of the cultivation, the yellowish greenish part what you see. This could be a initial cultivation like 0.4, 0.2, 0.5, you know, whereas 0.8 is a completely cultivated green land, okay, where the crop might have grown completely. So depending upon the NDV values, we can interpret and find out which area is what. Okay, again night vision. This was basically used for by the military or for night vision imagery and all that things. Okay. Introduction to photogrammetry. Photogrammetry is a science and technology of obtaining spatial measurements and other geometrical reliable deliverable products for photographs. Photogrammetry analysis procedures can range from obtaining approximate distance, areas, elevation using hard copy photograph products with the unsophisticated equipments. Like I told you the example of blinkometer, right? So blinkometer is very tedious. Like, you know, initially people develop those kind of equipments because you have to do something. But later on, because of the technology evolution, geometric concept for generating precise digital elevation model, orthophotos and thematic GIS data, digital photogrammetry has changed rapidly from the basis of the current photogrammetry. So if you see currently a lot of people are using, you see a lot of GIS data. We're talking about government in 2022 has released a GIS policy also, you know, and this year they are going to release the final policy. Even in this year budget, 1,000 crore rupees was given for GIS development, okay, by the finance minister. Okay, so there is a government is focusing more on the GIS data. The more amount of data you have with respect to GIS, government is trying to, I mean, the ISRO is going to send a couple of satellites in couple of years to completely have the area analyzed about the India and its neighboring countries also. Okay, so that is what where the GIS will be useful for various areas. Okay, mapping from aerial photography can take numerous forms and employ either hard copy or a soft copy approach. Orthophotography combines the geometric utility of map with extra real world information provided by the photographs. Process of creating orthophoto depends on existence of reliable DEM of the area being mapped. So it depends upon how much data you are capturing. As I said, manually when I was capturing the data, or even initially when we started fine tuning our flight plan for capturing the thermal, the power line tower images, initially we set it only for around 200-300 photographs. But then later on we have to fine tune it because we have to have a overlapping images. Okay, then only we'll have a lot of set of data available. So if I take a photograph of a tower of one position, then I take a next, then I take next. So there is no correlation between. But if I take them overlapping, okay, so I have to define in my software how much overlapping photograph I have to take. Either I have to take 50%, 60%, or maybe 80-90% also. So 90% overlapping means you will be having lot of images. Every 10 seconds your image will be captured, or every 2 seconds the image will be captured, depending upon that overlapping what I define. Okay, so in fact I can create using, if I stitch those images, I can actually create a video also. So video is nothing but it's a continuous. So in a second you are capturing 24 frames or 30 frames or 60 frames. The more amount of data you capture in a particular second, you will have more amount of data to interpret, and your more information is available for it. So the more data you have, the more better resolution. Like if you have only 10 photographs per second, okay, then you will see images like a animation. But if you see the real time images like movies what you capture, which is 24 frames per second, Okay, that's where you see a smooth picture. Okay, you see the thing happening in front of you when you are seeing the movie like it is happening in front of you, a real frame, right? That's the 24 frames. If you take more amount of data and you play in a normal speed, then probably you might feel to see it like a slow motion. Okay, so that is what it does. Normally in slow motion, when you are capturing in a slow motion, you are actually capturing more amount of images and then playing at a slow speed. That's why you feel it, the image is moving very slowly. But it is not the image with it, it's the amount of data what you have captured that is helpful. So when you want to see a particular object or something like a race, or when you are at the finishing line, that time you will increase the rate of images what you used to capture, because you may have to see it frame by frame, you may have to see it within a microsecond of data, so you require more amount of data. If you do not have that much amount of data, then you will lose the event information over there. So you have to have a very high speed camera. So that's why at the finishing line you will see most of the time they will always put a high speed cameras. So that is what you will have more amount of data, so you can go into the microsecond level split also. Okay, so drone data analysis: image gathered during the mission can be processed using software to sort, organize, and manage data. So initially we started project with 100 towers, but eventually they have to do it 12,000 towers. Okay, but for 100 towers also it was a huge amount of data. So every tower was generating, every time I fly a drone, it was generating almost 5 GB of data. So imagine 100 towers का कितना data होगा, and then imagine 12,000 towers का कितना data होगा. Okay, so initially we were capturing, putting the photographs on our local laptops, then on the hard disk. We purchased couple of hard disks to store the data. Then we saw that this data has to be utilized by more people. Okay, there were people who were working on the drone flight plans and all that thing by looking at this data. There were people who were analyzing these photos. There were people who were working on generating different types of reports. So a lot of people were actually asking for that data. So later on, from the local laptop to the portable hard disk, we moved to cloud. Okay, so we use technology over there, because that data needs to be analyzed by different peoples. Okay, so image gathered during the mission can be processed using software to sort, organize, manage the data content within the image processing tools that produce the final data sets that can be easily analyzed and provide valuable business insights. Okay, so when I said I did for 100 towers, I found almost 85 towers with the defect. How much? Out of 100 towers, I found 85 towers with major defects. Okay, almost all towers were having some or other problems. So I found out 85 towers having major defects. Okay, so after generating the report, all this was done initially all manual. Okay, it took us 3 months to do all this analysis and set, and we were working almost 18 to 20 hours a day during that time, and we were analyzing those photos, images, trying to put it in a reporting format and all that things. And once we submitted, the board actually took the decision. They put up vendors to get all those towers rectified. So after a period of 6 months, from 85 towers with major defect, it went to 35 towers. And by that period of 1 year, we completed our POC. We were only having 10 towers with minor defects. So almost 90% of your towers, or 90 towers, were error free or defect free. So that is what they're seeing, and that is why they were seeing that in those towers. So we have taken one small region, okay, and that region we saw that there was hardly any outages, because all work because of this project using the drone was a pilot project to see whether drone was used. Because earlier people used to carry, there were people going to these towers. I'll tell you how they used to do this activity prior the drone. There was people going in a jeep to all these locations wherever the towers are there. So mostly the villages in Bihar and all that thing. They used to go carry the DSLR. They used to go to the tower, capture the photograph from the ground. So you imagine the photographs which are captured using DSLR. Though they were having a good DSLR with the zoom camera and all that thing, still the images what we captured from the drone and the images captured from the ground is different. There is a person who also has a binocular. So they used to do manual observation of the tower also. So this is all traditional way of doing it. And for example, they have to 10-20 towers. It used to take 20 days, 10 to 20 days of activity, because एक tower को manually करने के लिए उनको कम से कम 2-3 घंटा लगता था. So in a day they were only able to do 2 towers, 3 towers, 4 towers. 5 towers max to max, not more than that. Okay, so it is a very lengthy process. And after a week's time, they will come back to office. They will put down. I mean, whatever the observation was, all manual observation. Whatever the photographs they have taken, they have either they have digital pictures or they have initial earlier older times they were using on film camera. So those pictures used to be processed. They showed us all those data also. Okay, the photographs, the hard copy photographs also, and how they used to analyze those photographs and give the reports about the problem with the towers and all that. So this was very reactive work. By that time, वो tower में कुछ ना कुछ problem होता था, or there was outages happening, line cut हो गया, insulator break हो गया, problems used to, a lot of theft also used to happen about the tower. People वहाँ पे वो tower का बाहर निकाल के लेके जाते थे, nut bolt loose करके निकाल के लेके जाते थे. So they have to put a barbed wire. All that things they have to do it. Okay, and then even bird nesting hota tha. So because of that also there was a lot of short circuit protection and all that things. So they have to do all these things. So this was all done traditionally. But once they have this data, we analysis, we progress. Even we learned a lot of things from this project itself. Right from doing it initially manual level to automizing it using AI and ML to come to us such a way that once we have a data, my pilot has flown initially. Like initially it used to take, as I told you, maybe 2 weeks of time used to take for us to generating the report. But later on, once we completed the project, this entire process, like for example, if I give an example, if I flow a tower, okay, a pilot flies a drone near the tower, he captures the data. Within that same day itself, you used to get the report of that particular tower, the health of the tower. Okay, that efficiency we brought it into it. So they were able to do lot of proactive works, okay, corrective works, what we supposed to, and that has reduced lot of outages. कभी-कभी कैसे ना वायर टूट गया तो 2 दिन पावर ही नहीं गांव में. 10 villages used to affect for 1 or 2 days unless the new wire is been put or the rectification work is done. So the board is losing the revenue because there was no power for 2 days. For तो 2 दिन के लिए revenue नहीं generate हो सकता है. Again, the people who are there in that villages because of no power, they are also losing their day-to-day, work, what they were supposed to do. They are not able to do the work. Okay, the hospitals were not powered, the schools were not powered, the industries what were there in their area, whatever the small industries were there, they were not given power. So they were all losing revenue. So it is not only the power board losing the revenue, but even the other people in that community or society, they were losing lot of revenue there. So there is eventually lot of revenue losses was happening. But because of this project, see how much immensely it has helped a power board as well as the people in that area. Okay, so see the importance of adoption of a drone in a such activity. This is just one of the use case or one example I am giving it to you. So there are different examples, like I told you about the water pipeline also. By using the drone with the thermal camera, we were able to predict that where my pipeline is going to get damaged or is in a damaged situation. I have to do immediately repairing work for that particular location. Okay, and then make sure that that issue is not there. नहीं तो अगर suppose कल pipeline फूट गया, then it will loss of water. Plenty of water will be lost. Again, you have to shut down the entire region and do the bigger repair work and all those things. So if there is a smaller activity I can do, I can take a shutdown for 1 hour, 2 hour, 3 hours and rectify that problem. Rather अभी फूट गया तो I have to do bigger repairing work over there. So this is how we are saving millions of rupees over there. Millions of wastage of resources was there, which was reduced by using drone. So see where the drone can be useful. Okay. So if desired, the data can be turned into 2D or 3D maps. So when we exited from this project, since I moved out from that company which I was working with that as a freelancer, end of that project, phase 2 was basically they wanted to develop a real-time portal where you just like a Google Earth, you just go to that particular location, you click on the tower. In a real time, it will show you the 3D or 2D image of that tower and give you the health of the tower. So you can historically see the data also. So that is what basically the drone data analysis what has been done. Okay. So storing and analyzing drone data for every mission. So like I have captured images in January, then I have captured images in April, then I have captured images in June, then I have captured in October, then I have captured it. So I have every 3 months I had a data. So every time I can always do a chronological data analysis or see how was my tower in January, what was the health level of that tower. So they have created a very good what we say ratings for the towers. A tower with a zero defect was given 10 points. Okay, and tower with maximum defects was given 0 point. So if the tower is having higher rating, it is a good tower. Okay, so that is also you will see. They were also created some visual interpretations also. There were four or five color coding they have used. So the green color means what is a 100% good tower. Okay, then followed by different colors. So red tower means it's having a major problems. Okay, that is how they have. So there are different way of interpreting the data based on whatever the data is. For example, including the progress on the construction site, number of materials stored on the specific location, incremental degradation of wind turbine blades also. Like you can do the wind turbine blade analysis also. Like normally you have to stop the wind blade and monitor each blade manually, which was a very tedious task. Okay, and very what we say risky task also, because the person who has to visualize, he has to climb the tower. Okay, and then he has to see every tower. I mean, every blade he has to walk. He has to actually climb down the blade and see each and every point. So it was very difficult, manually doing this analysis of the wind turbine blades also. By using drones, you get a real good footages. Okay, and you can make sitting in your office, you can find it. So rather sending a person on the wind turbine or the thing, which is a risky activity in itself. Okay, so this was reduced because of the drone. The final report. So once we had given a report to the board about the tower, and then board has given to their stakeholders an executive report based on our report. A final report can be generated to share with the key stakeholders and decision makers to review and take further action. So after our project POC was done, the board has taken a decision to set up a division with the drones and the people to analyze and all the things. So they were asking us to join their company or their board and all things. But since we had a bigger vision and bigger things to see, we didn't join those companies also. But then we recommended some good people who had worked with us, some pilots who had worked locally over there. They got insourced into that job. So there was a good amount of job being generated by this particular projects also. Almost like 20-25 team was set up during this entire project activity. Okay. So ways to view the drone data. Depending on your software you utilize, you should be able to view your data concisely in the following ways. Like you can generate CSV reports, PDF reports, charts, graphs, and tablets. Okay, tables. Sorry. Perform analytics, including the performance figures like order, mission, inspection, flight, pilots, data. Like I told you, like how much. I mean, executive board showed them that in last 3 months there was hardly any outages. Okay, so and then they have shown that historical data back of 1 year, 2 years in a same period of time from January to March 31st. In that 3 months, let's say you take example of 2025, 2024, and 23. So they have shown that in 2023, 2024, there was a lot of outages at that point in time. And during this period of when we were actually using drone data for analysis and recommendation, mitigation plans and all that things, there is a strategically reduction in the outages. Okay, almost we were able to make outages 0%. Okay, until unless there is something which is not beyond the drone data capacity. Okay, जैसे फॉर एग्जाम्पल कहीं पे किसी ने lot of people in this rural area, they do lot of damages to these towers और छेड़खानी करते हैं पावर के साथ and all that thing. So that time the outages happens. So short circuit हो जाता है and all this. And people चोरी करते हैं ना इलेक्ट्रिक का वायर पावर का. So that time short circuit happens. So those are different types of outages, not related to drone. But then outages for them. So there is something where we cannot do anything with the drone. Like किसी ने उधर से वायर शॉर्ट करके वो बोलते हैं what is that called, hooks. The people put hooks. Okay, so sometimes वो short circuit हो जाता है, तो outage हो जाता है वो टाइम पे. So they have to come back because 2 वायर अगर शॉर्ट हो गई तो पूरा पावर लाइन ट्रिप हो जाता है, तो फ्यूज उड़ जाता है उधर का. So the person has to come to that location, change the fuse और वो जो strip होता है उसको ऊपर करना पड़ता है. So that all that things will take some time. But then even if it takes 30 minutes, 40 minutes, 1 hour, outage is outage. So but those are some things which is not under the control of drone. Okay, so performance analysis, return of investment, ROI, you can track the efficiency, safety minutes. So they saw huge potential, and that's why they thought of setting up the team and utilizing this new technology for their monitoring of their towers. Okay, so data mapping, navigation with user, graphical user interface to navigate 2D, 3D models. See, this is what I was talking about, the last phase of the Powerline Tower project, where they wanted to create a real-time platform to see the real-time data about their towers. So they go on that portal and they can just scan, and then they can just see the data of their towers and the health around that tower. So they can find out the CEOs or the board members. They can actually see each towers at their at their laptops, desktops, or on their tablets at given point in. So they were talking also about developing some kind of app also, so that they can see it on the mobile. Okay, so all the information will be available on the mobile app. But then that was a very futuristic, or it was not really required, because app will not give you any, but it was just easiness of seeing the data availability, that's it, or kuch nahi tha usme. But there was no other advantage of developing an app around it, unless you have some commercial availability of it, then only it will be useful to develop an app. Or else whatever the development was done so far on the web platform was more than enough for them to sustain and do it. Okay, so with that, we complete the introduction to drone data and analysis. You have any other questions? Any questions to discuss on this particular topic? We can take up. Or one or two questions from this topic, just to give you an idea. Digital surface model. Terrain model. Right, so understand one thing, the word model is important in your answer. Okay, if sometimes there will be all three options will be available with the model, but then you have to like direct energy to nahi hoga, direct environmental to nahi hoga. Okay, so you have to understand, that is how you interpret the answer also sometimes. Okay, so digital elevation model. Last question. Correct. Last question. What is the primarily use of visible blue light in drone data? Blue light, vegetation discrimination will not be in blue. Water penetration. Solar panels. See power lines, it will be used. It will be used in wind turbines also. Okay. But what is the most suitable for inspecting? The word, you have to understand the word. Most suitable. Okay. Solar panel is the most word. Because solar panel is what? It's related to heat, right? It's capturing the solar energy. So you want to understand what is actually the way the solar panels are there. So in solar panel monitoring, you use thermal images or thermal sensors. Okay. So with that, we cover all the topics. We have completed all our topics. I will just do a small orientation about the digital sky platform, and then we can wind up. Okay. If you have any questions, you can ask. Okay, so let me put up the digital sky platform again. Yesterday I have shown you about the digital sky platform. Okay, so this is a digital sky platform. Initially, when after drone rules 2021, this was also launched by the DGCA. Okay, so this is basically with respect to the drones. Okay, so there is another another platform by DGCA. This is actually the real website of DGCA. So this website is going to merge into this website. Okay, or it is going to come over here. Okay, all your drones related things will come here. So there is a migration which is happening in backend. I think I do not have any update as of now how level or how much it's there, but I see that at present there is no activity happening on the migration side. That's what we understand. Okay, that's the internal information what we have. There is no official communication from DGCA. Okay, but we hear every time that this platform is going to move into this website. Okay, the DGCA. But as of now, we are only interested in the digital sky platform because there are some functionality which is useful here. Like if I want to apply for certifications. So D1 form I can apply, D2 form I can apply, I can do for D3. D4 currently activity is stopped over here. Okay, so we cannot apply here online. Okay, even D5 activity is somewhat also not applicable over here. So only first three options are available. Even creating a flight plan, some extent it is useful, some extent it is not useful for us. Okay, adding the branches for the RP2 is there. Train the trainer authorization. This is the new parameters what they have added recently. For example, when I complete more than 100 students, then I can apply for train the authorization for our RP2. That means our RPTO can also create trainers. Okay, not only the pilots, but we can create trainers also. Okay, so then we can do all the things. So we need at least 100 people to be trained for this activity. Okay, then you can see issued UIN. So the people who have registered their drones on the platform. So right now you can see there are 33,427 drones registered over. So this number is very less compared to the amount of drones what we have in our country. So this number should be somewhere around 50,000 to 60,000 numbers. Okay, so still there are people who have not registered their drones. Okay, so that's what we see the difference. So you see here from 2019. So initially the data was ported manually through some platform, and that's why. So that's why you see here 2019 mein to nahi tha, right? The platform itself was not there. The platform was ready in 2021, but there was some historical data they have captured and they have put it. But you see the model type PA, okay, whereas a type certified drone will have TC. Okay, so TC will be the type certified drone. PA is nothing but a non-type certified model which was provisionally accepted. That means before the drone rules 2021, these drones were accepted. Then there are some models like EN or EX. EX are basically type certified, not required for operating model or nano remotely piloted aircraft system RPAS or nano US. Okay. So as per rule number 3, the drone UIN issued for model RPAS cannot be used for commercial purposes. So actually, if you see wherever they are showing X, right, those drones, like especially the DJI drones, okay, what they are saying here, see. Let's see the DJI drones. See here this Mini 4 Pro. Okay, though this is again a nano drone. So anyway, nano drone is exempted from using commercial or anything. Okay, but then it is X. But you can see, let's see, there are some drones which are bigger in size. So these are all less. You see, weight is very less. 240, 249, 240. So these are still beyond the limit. Okay, if we have X here, X. Okay, here there is a drone which is again called, it is in a small class, but it is not given a TC, but it has got the UIN number. It has a weight of almost, so this may be a drone which has got the UIN number and currently it is in prototype. Maybe they have applied for type certification. Once they get the type certification, maybe this drone will convert into TC. Okay, so this may be 24.9A, so maybe this could be a agriculture drone. Okay, as of now it may not be having a type certification, that's why it is given X. Okay, so they cannot use this drone as a commercial purposes. Okay, you can see here another DJI 4 Mini 4 Pro. Okay, still it is again in a nano also. I don't know. Okay, Mini 4 Pro. I want to see if there is a phantom drone. Let's see. Okay, see now here DJI Phantom 4 Pro. Okay, it is given EN. EN means what? It is enlisted as a DAN model. Okay. Now again these are during those 2021 only. Let's see if there is any latest one. 9th one. Let's see the 9th one. Okay. So latest DJI Phantom drone is given EX. Okay, though it is in micro category with 1.3. They say that this drone is registered, this is having UIN number, but cannot be used for commercial purposes. Okay, so they are getting listed, they are giving you UIN number, but they are not telling you. I mean, they are here itself clearly saying you cannot use this drone for commercial purpose. You can fly this drone for your own purposes, but you cannot. But do you think that DJI Phantom 4 with RTK, they will using it for fun or anything own purposes? They will be using it for commercial purposes only. Okay, these people. Tripathi Aerospace Private Limited. Let's see what is this company. Okay, we can find out. Okay, so see they are actually into some kind of a surveillance activity probably. Fly and capture technology with intelligence. See if they are doing this. See this is the drone what I was talking about. Phantom 4. Okay. Do you think that they will not use this drone for non-commercial activity? It will be commercial activity only, but this is illegal. Okay, they are using it for their own purposes. So let's see what are the services. Manage all your aerospace required in one space. Drone manufacturing, inspection, monitoring, survey, surveillance for mining, all that activity. So they are doing all commercial activity only using that drone. Okay, since they might be using it in mining areas. Okay, so that they are actually in mining area, people ask that you should. Even a lot of people emphasize that whatever drone you use should have a UIN number. Not only type certification, but then you should also have a UIN. At least you should have a UIN number. So, that's why you should register. That's why they may have registered their drones. Here. Or here see you, Indian Institute of Technology. Even their drones are being. So, maybe Indian Institute of Technology may be using this Phantom 4 drone for research purpose, some activity purpose, some research. So, this educational institute may be using it for research purpose. So this is valid. Then it is valid because they are not using it for any commercial activity. Okay. You can see a lot of people. Individuals here also like Bipin Prasad. Okay. He is using Phantom 4. Okay. Again it is X. Do you think that Bipin Prasad would have taken Phantom 4 for just for fun? No, right? Nobody will invest money in this type of drones like Pranal Roy NB Raj, okay, Phantom 4 Pro version 2.0. So these drones are very expensive drones. Nobody will just take it just for simple flying, right? Especially Phantom 4. Phantom 4 is a commercial drone. You see almost how many drones are there? 444 drones, 445 drones. So all these 445 drones, they are being categorized, they have a UI, but they are all being used for commercial purposes. Though here they cannot be used for commercial purposes, but they are saying it. Okay. Then UIS model. Okay, this is all about type certified. So currently 114 drones are being certified as a type certified. So we are actually using this drone for our training purpose, AgriBot. So you can search here by name IoTech. Okay, so we are using this AgriBot and we are using AgriBot A6. These two versions of drones we are using for our training. So we are also in process of procuring this once we have our medium category authorization. So we'll also have a AgriBot MX, or we are also given an order to Marut drones also. Okay, so we will be having again either AG365H or AG365. Either of these two drones will be available for us for our medium category training. Okay, once we start. So that about UIS model. Then training is basically all the how many 170 are there, but 50% of RPTOs are non-functional or not working. Like if you see our example, okay, if I search Control F and put Bombay, so we have two names, okay, but our only this is operational. We are not operating at this location, or this is basically for our Dule location. Okay, so this is not functional as of now, but we only this. So similarly, out of 170, I can say very easily, I can say that 50% of RPTOs are non-functional or not functioning currently. Okay. Then remote pilots. If you see number of pilots, so right now here it is showing 3,566. But if you see the data may be only up to what February. Okay, some data is there, but maximum you can see 23, 24 only is there. 25 you would hardly see. So last 1 year there is no updation happening over here. So 13,566, whereas we have drone 33,000 drones. Okay, if you see here we have 33,000 drones, whereas remote pilots we have only 13,000. Okay, so you see there is a huge gap. Even you double this will become 26. Okay, but there is a gap in this. So you have to add another 3,000 to 5,000 pilots. So roughly this number would be around 18,000, or on a higher side I can consider 20,000. But still 20,000 compared to this, again here this number is also less. As I was telling, this should be number around 50,000 to 60,000 number of drones. So you see there is no 100% capturing of data happening over here. Okay, or even here. Okay, because nowadays the data is not, I mean the amount of pilots which are getting trained, that this is not getting updated. Okay, this will get updated later on once we move to the new website. Okay. As of now, it is only on manual way. Okay, they are tracking it only manual. So every week we have to send, like as we complete our batches, we will send an Excel sheet to the DGC, and DGC will consolidate, and then they will create a report. Okay, and then they will release that these many people were trained by so and so organization for remote pilot trainings. Okay, so this number would be around 18,000 to 20,000 only. Okay, so this is all about the digital sky platform. As you scroll down, you can see, if you go on the first page, okay, you can have these forms like type 1 form, for type certificate D1 form, unique identification D2 form, UIN for D2 for model or nano UIS, and transfer unmanned, okay, or maybe deregistration of this, remote pilot certificate D4 form, okay, authorization of remote pilot D5 form, create a flight plan, add a branch or RPTO, train the trainer, all this. So the same thing is available here with more detailed explanation how to do it. Okay, how to do it. Okay, as of now you don't require to do anything. Earlier we used to tell our students to create a login over here. Okay, but there is no use of creating a login over here because it's a waste, because it will not get linked to us. You will get directly later on, once we move to the new website, you will get a login over here, or you will be asked to create a login over here. Okay, you will be asked to create a login that is called EGCA. Okay, EGCA login you have to create here later on. Okay, so we will be telling you, we will be reaching out to you in the near future whenever this is up and running for our pilot recommendations. Then we'll be actually asking you to create, and then we'll be maybe uploading all your data over here also. As of now, we are sending, or maybe DGCA do it in the backend itself. Okay, so they may ask you and then they may send you. That's why they are collecting your email IDs and phone numbers. So maybe in future you will get directly mail from the DGCA once this portal is active. But I am not sure when and what will happen. Okay, that is what only we have some amount of idea from the government or from the DGCA. Okay, again on that you can see, I mean, only important thing on that platform is about the documentation part. Okay, you can go to regulations and guidance. You can see here act and rules, the Aircraft Act 1934 which I spoke, it is available over here, right? You can read each and every line item here. Okay, if you go to then rules, okay, you can see act rules. Even here you will see your you see your aircraft carriage of dangerous good rule 2023 2003. Okay, aircraft investigation and accident and incident rules 2017. You can see your drone rules 2021, our same document which I showed you or which I mailed you, 43-page document, that is also available on this website. Okay, and you can see other things also, like you see a car, all the cars are there. Okay, so you can see section 1, section 2 and all that. Okay, or you can see circulars, aeronautical circulars also. But as of now, no point wasting time over here. Okay, only refer the documents which I have shared to you. Go through the summary sheet, read that multiple times. You will be able to, if you have any query, we'll, anyway tomorrow when we are meeting, we are going to discuss about our theory sessions. We'll be having a quick survey overview of our sessions, what we have done in last 2 days, and then we will go for the test. So any questions we have, or we are good to wind up for today's session? I just want you